Hello everyone, I am Kailash. Our project is classifying Cifar 10 dataset using CNN and residual networks. We have two Jupyter files, one for the CNN and the other for the ResNet approach. The below table summarizes the final accuracy information from the two architecture we have used. Cifar 10 dataset is one of the most widely used dataset for image classification. It consists of 32 by 32 pixels. The label data corresponds to one of the 10 classes such as the airplane, dog, cat, etc. As in the figure, we are using the reshape and transpose function to reshape the input data. The display stats function helps to print the information about the batch data. Here you can see for the batch ID 3 and the sample ID 7000 represents the airplane. After doing normalization and one-hot encoding, we are splitting the data in the 90-10 percentage for our train and validation data set.
Hello everyone, my name is Siddharth Bhola and I will be presenting to you our convolutional neural network for classifying Cipher 10 dataset. We are using TensorFlow for developing our CNN and which uses data flow graph to represent computation. Data flow is a common programming model for parallel computing where the nodes represent units of computation and the edges represent the data which is being consumed or produced. Now let us look at our convolutional neural network architecture. The entire model consists of 14 layers in total. Input layer is a 32 by 32 layer with 3 channels, red, green and blue. We feed this input layer to a convolution with 64 different filters of size 3 by 3, followed by max pooling, ReLU activation and batch normalization. We apply the above convolution and max pooling multiple times and increase the number of filters. Then we have 4 fully connected layers with 128, 256, 512 and 1024 number of filters. Finally, we have a fully connected layer with 10 units, which is same as the number of image classes. Let us now look at some of the building blocks of neural networks. First is padding. We have used same setting for padding, which will ensure the same size of the image after convolution. Max pooling, it is a sample based discretization process of which objective is to downsample or downsize an image, reducing its dimensionality. When we run the above architecture for 10 epochs, we achieved 73.3% test accuracy. And when we run the above architecture for 50 epochs on AWS, we achieved 78.01% test accuracy. Looking at this graph, you can see that validation accuracy increases and loss decreases as the number of epochs decreases. Thank you.
Hi, this is Rekha. In CNN, when the network is too deep, it starts facing vanishing gradient problem. And then we read about ResNet architecture in which the gradients can flow directly through the shortcut connections backwards from later layers to initial filters. So we decided to go with ResNet to achieve a better accuracy with few layers deep. After loading the Cipher 10 data from Kira's dataset, we normalized it using 2 steps. We defined the learning rate schedule in such a way that it will start with a relatively high learning rate, and as the number of epoch increases, the learning rate reduces gradually. In addition, we used image augmentation to enlarge our training data and also to prevent overfitting. Then comes our ResNet architecture. Our ResNet architecture is 20 layers deep. After the input layer, we have a 3 by 3 convolution layer with batch normalization and ReLU activation. Following this, we have 3 stages. At the beginning of each stage, the feature map size is halved and the number of filters is doubled. However, within each stage, all the layers have the same number of filters and the same filter size. To explain stages in detail, stage 1 has 3 residual blocks, with each residual block contains a stack of 2 layers of 3 by 3 convolution layer with batch normalization and ReLU activation. And the last ReLU activation is performed after the shortcut connection. Stage 2 and 3 are equivalent to stage 1 with the exception that the convolution layer of first residual block uses a stride of 2 where the map size is downsampled. Since the dimensions have changed, we used linear projection of residual shortcut connection to match the changed dimension. Following the 3 stages, we have the average pooling layer and then softmax classifier which is applied over the flattened inputs. We ran 2 batches, one with 10 epoch which gave the accuracy of 74% and the other with 50 epoch which gave the highest accuracy of 85.32 among all the models we have tried. So currently we have used version 1 of ResNet. So in the future we will implement version 2 to boost our accuracy. Thank you.